So this is hopefully the last video you'll need before you can start with the data extraction process. And this will hopefully cover the last of the somewhat complex issues that you'll face when doing this process. So we're going to talk about dealing with multiple subgroup comparisons, as well as how to handle the outcomes when there are more than 5. So for example here, what to do when there are more than 5 outcomes within a specific cognitive domain, because then the Excel sheet cannot handle it or deal with it. So let's talk about the article 15/2012. So in this article, there are 3 different subgroups. There are 9 to 12-year-olds, 13 to 16-year-olds, and adults. They want to look at the effect of concussion across age. So you have 3 subgroup comparisons. Now, each concussed group has its own control group, so they are not the same across all of the different subgroups. So they're independent of one another. So in this case, when you look at the initial data extraction sheet, the Excel file, the control group data is going to be different for every single one of these domains. But what the data will look like is, even though the outcomes are exactly the same, so single digit modalities, and single digit modalities, what I'm having the undergrads do is label the specific group that it's coming from. So these are the 9 to 12-year-olds, these are the 13 to 16-year-olds, and these are the adults. Now, on the other hand, you might see a subgroup comparison where there's only one control group. So in this study, they're looking at orthopedic injuries as the control group, and they're comparing it to folks who have sustained a TBI with a loss of consciousness versus folks who sustained a TBI with no loss of consciousness. So in this case, there's only one comparison group, but 2 subgroup comparisons. So what the data looks like is a little bit different. So again, we're going to have the undergrads label specifically not only the name, but what subgroup it's coming from. However, the control group data is going to be the same for each one of these outcome measures. So for example, for the WASI FSIQ LOC, the control group mean is 98.9, standard deviation 15.1. The WASI FSIQ for the loss of control group, again, it's literally just copied and pasted. So this data is exactly the same as these data right here. And the reason for that is it's the same exact control group, so we're making the same comparisons across that. So that's just something to be wary of. Now, what that means when you have multiple subgroups is you'll do the data extraction where you're copying and pasting the data exactly the same. So you'll come across here, find the cognitive domain it belongs to, and copy and paste it into the, like I said, the specific cognitive domain, and it'll automatically calculate it for you. With the phase sheet, you will see a little bit of differences. So for example, the age here is not the age of a specific subgroup. It is the weighted mean age across both concussion groups. So if I'm coming back to the original article, 15/2012, and I try and find the age, I'm going to do the weighted mean. So the overall age is the weighted mean of the concussed groups for this 9 to 12-year-olds, the 13 to 16-year-olds, and the adults. What I did is I just Googled weighted mean calculator online and entered in this information to get a weighted mean of 16.89 years old, and that's based on these 3 groups. Weighted means meaning that it's not only an average across the 3 groups, but the group that has a larger sample size is going to obviously weigh higher than or create a higher weight for the overall mean than any one specific group. So for example, if this group had 100, then the weighted mean would be closer to 23.3 versus these that only have 16 and 17 respectively. If that doesn't make sense, let me know. I'd be happy to explain that a little bit further. So just something to be aware about, or to be aware of. The data might look a little bit different with the extraction when there are multiple subgroups, but I talked to the RAs, or I made a video specifically for them on how to do that. And again, when you're calculating these data here, these are weighted means based on the specific subgroup comparisons. So last thing I wanted to talk about is dealing and handling the data when there are more than 5 outcomes for each specific cognitive domain. So let's talk about processing speed. So if I come over to the data extraction that the RAs came through, there are lots of processing speed measures. So we have simple digit modality, but there's 3 of them because there's 9 to 12-year-olds, 13 to 16-year-olds, and the adults. So there's 3 simple digit modalities. There's 3 color trails, which is essentially trails A, which is a processing speed measure. So between the 2 of them, there's going to be 6 different outcomes. The problem is that this is only built to handle 5 different outcomes. Well, the good news is that this extraction sheet already calculates the effect size for you. So all you have to do is copy this entire sheet, put it in, create a new sheet. So in this case, I just hit this button here. It created sheet 1, and I just copied and pasted all that here. What I did is for the specific measures where there were more than 5, I just calculated an average based on what was already done here. So I went through, if I needed to reverse the effect size, and I reversed the effect size, so on and so forth. So I, sticking with processing speed, so I just did average, and then I went through and I just found all the different processing speed measures and calculated a weighted average, just an average based on those different outcomes. What I then did is I came over to the independence groups only, and I just wrote in that data for the average right here. So typically what this does is it'll calculate the average across multiple cognitive domains. So for example here, this is the average of these 3 here. What I did is I just put in the actual information into these bottoms right here. So negative 0.072. Negative 0.072, and then a standard error of 0.355. Again, this is 0.355. So just copy and paste that here. What that does is that automatically transfers it over here. So again, negative to the face sheet. So negative 0.07 effect size with a standard error of 0.355 here. So I'll keep this extra sheet here just as a reference. What I should do is here for the outcome, I should write something down like C sheet 1 for full data. Same thing with, and then I'll, there's another one to the memory. Oh yeah, so C addended sheets, C addended sheets. That's what you should do with the test names. So I'll do say C addended sheets. So if I or someone else needs to come back and take a look at this and see where these numbers are coming from in case there's any problems, then what I'll do is I'll see addended sheet, and I know to look here to figure out how you calculated the effect sizes for these different domains. Hopefully that makes sense. The one thing that you do want to be careful of is prior to copying and pasting from the initial extraction, make sure that if it needs to be reversed, so for example, trails B, so color trails T2, if that needs to be reversed, make sure that you click that box first so it reverses the effect size. Then when you copy everything, make sure you copy it and then paste special. So you'll paste special, so it's just the numbers, so it's not pulling everything with it. Otherwise, if you see here, it's going to be pulling, for example, I didn't do that, and that was problematic. For example, here it's pulling all this data from the other sheets, which is not good because then things can get lost in translation. So I actually need to go back and fix this and make sure that that's correct. But otherwise, the take-home message is to make sure that you are just creating an average based on every single one of those cognitive domains and outcomes. How you choose to do that's totally up to you. So if you want to organize this and put all of the processing speed measures right next to each other, feel free to do that. If you want to put all of the memory measures right next to each other, copy and paste, feel free to do that. If you want to do like I did, where I just did an average and then clicked on the specific ones, totally up to you, just as long as the data are accurate and you're being systematic about it. Other than that, I think that's the main two things that might be problematic moving forward, is handling multiple subgroups and also what to do with the effect size calculator if there's more than 5 measures. Hopefully that's clear. I know I kind of rushed through that, so if you're not certain or you have any questions, let me know, or I can just make another video if that may be a little bit easier. But please, please, please let me know if there's any questions lingering from this. Thank you so much.